we
Okay.
still have
5 minutes. 4 minutes. Yeah, so that's it.
How many students we have in the class? 50?
Well, today was 40 students responded to the poll, so that was the highest number I've had so far for the poll. And surprisingly, they didn't ask for problem 3, they asked for problem 2.
Really?
Yeah.
They made a mistake.
It's okay. It's okay. It'll be fine. It'll be fine. What was that? Yeah, they're having a good time. They have other things to do in life. I don't know. No, that's not nothing.
You're nervous today. You're nervous today.
me.
Mm.
Well, yeah, of course.
Why?
Because I was doing it all
Alone?
on my own.
Yeah.
And I wasn't sure, we haven't completely figured out the audio yet, so I was testing out some things and was testing out the tablet for the first time.
Yeah, that's
Oh,
good.
yes,
A lot of
yes,
like
it was.
uncertainties, and then there was no Surface Pro, which is,
Yeah.
is totally fine, it all worked
Well,
out.
it turns out it's okay.
Yeah, definitely. So just lots, yeah.
What's to
And
do?
in fact, you didn't have to use the tablet. It didn't come up today, like it was on before.
Yes,
But
there
it's
was
still
nothing.
nice to have. So, okay, so just to know, going forward, let's say Monday's session, should we use the Surface Pro? Should we have I'll keep the Surface Pro and give my laptop to Notion the way you had it today? And what's your preference?
I mean, what's your preference to use? Because you're the one that's using the computer,
That's
so.
good. That's good. You prefer writing on Surface Pro or on the tablet?
Doesn't matter for me. It's
Well, the
better.
tablet writes better, so if you, yeah, it's just, I don't know how good, are you good with using Danny's laptop?
I'm okay with that.
Yeah.
Yes.
Yeah, so I think we should give the tablet more time, more use, to get used to it, to test it out. Like, we know what a Surface Pro is like, right? But if we notice that the tablet's really good and better than writing, for that kind of thing, then we'll get one or something, or whatever. You guys only have one, right?
Yeah. You want to get one for yourself?
Well, we don't really need it, no, not.
I mean, no one's using that one right now. so
Right,
it's
exactly,
free
so,
for this course.
exactly, so we'll use yours until such time, if we ever need it again, we know that it's a good thing to have, but those things are expensive.
Okay, 3:59.
359, okay, I think we're
Okay.
ready to go. Okay, but that's to be close to you, because when
Yes.
you move, then it moves.
Okay.
It's following you.
Really?
You see, yeah,
Oh.
walk back and forth, and you'll see.
No. Yeah.
He has an instruction, following Lucian. Okay, so here we are in the tutorial for day 4. Lucian was explaining about the X-bar and R chart, and then there was a request to continue that explanation, maybe for her to make a video. And I thought, well, maybe she should present what she was presenting and do that as a tutorial today. Then you can ask any questions, and then I'll take over after that. Okay.
Okay. Hi everyone. There were too many questions about R and X-bar chart, and some of you had problem with question of day 3 assignment. So I'm going to explain it for you. Whenever you have a question about R chart, S chart, X-bar chart, you need to start with the chart related to the sigma. Here the chart related to sigma is R chart. Okay, so start with the chart related to the sigma. Find the UCL and LCL for that chart. And the center line. So, with using Minitab, you can find the UCL and LCL for R chart. The only thing is that in the option for the R chart, you can click on the estimate, and then your estimate of a standard deviation should be based on R bar, not the pooled data. So you check your samples, and you can see an out of control or 2 out of controls. So you need to delete these points. You delete these points and again update your chart. Updated. UCL and LCL. Now, for example, here you had 20 samples. By deleting 2 of the samples, you have 18 samples. So, you have 18 samples, and you draw all of them, and you can see all of the data are in control. So, you can stop, you can estimate your sigma based on the R chart. Sigma estimate is R bar over D2. This D2 depends on the sample size. For example, in the assignment, D2 was for n equal to 5. So you estimated your sigma, which is the one of the model parameters. Then you can go to the X bar chart. So for the X bar chart, again, you need to have a center line, UCL and LCL. If you're using Minitab, in the option for the X bar, you can mention the estimate of sigma that you found from the previous step. So you find your estimate of sigma, for example, 5.2. Then in the Minitab, you have an option for X bar, and in the option for the X bar, if you click on that, you can mention the estimate of the sigma. Then you mention the estimate of the sigma, you can find the UCL and LCL for the X bar. The important thing is that you have the X bar chart for the 20 samples, the main data that you had. If you deleted a point from R chart, do not delete it from X bar chart. Now, if you have an out of control for X bar chart, delete that point and update your chart again. Now, you have 19 data here, and all of the data, for example, are in control, so you can estimate mean. Mean is equal to X bar bar. This X bar bar, the updated one. If you have an out of control in the X bar chart, do not go back to the R chart because you estimated sigma. Sigma is in control. You don't need to delete the point from R chart. And that's it.
I have a question here. Would you please tell me one more time about finding an estimate? Is that related?
Okay. For the estimate of sigma, if you are using R chart, it is equal to R bar over D2. Okay. When you update your chart and when all of the data are in control, you can find R bar, so which is the center line. And then based on the R bar over D2, you can find sigma. D2 has a table. You can find it in a book or internet, and it depends on the sample size. For example, in the day 3 assignment, the sample size was 5. So you need to find D2 for the sample size of 5. And the other thing is that it depends on the sample size, not the number of samples. Some students make mistake. So this is the estimate of sigma. For estimating of mean, you need to have the in-control data from X bar chart. So you can estimate mean based on the X bar chart. And the other thing is that if we ask about the model parameters, you need to estimate sigma and mean for us, and you need to mention it. Is there any other question?
I don't have a question, but I just looked up the internet D2 table, find any place there's a number of them. It's 2.326.
Oh, for n equal to 5?
Yeah.
2 point?
2.326.
For n equal to 5.
So these values are very easy to find and fact practical.
Is there any other question?
And finally, when I need to create an X bar and R chart, do I need to delete that 2 points on the R chart?
Can you repeat the question?
This is, yeah.
Okay. So this is where I'll stand close to you.
And you have
so
to repeat the question.
I have to repeat the question. Yeah. So the question is, do we then produce the X bar and R chart together again? Is that your question? Yeah. So this is a point of contention, not of contention. This is my flaw, my fault. What I do is I feel lucky and I produce both of them, hoping that they will be in control, right? But if they're in control, then I'm done. But if they're not in control, then I have to go through this process to first get the R bar, get the sigma, put the sigma into the X bar, make sure that all the X bar points are in control. Then one is finished. Now on the video, I did go and produce the two again, with the mentality that maybe management or whoever is used wants to see both of them, okay? Strictly speaking, that's not right, because you then are, if the two charts are excluding different samples, if they're both excluding the same samples, that's okay. But if one is excluding two samples and the other one is excluding one, or they're excluding different samples, then that's not quite right. It's not correct. It's on the video. It's a mistake. It's wrong. Okay. So I need to take that back. I sort of did the loop. I started with both, did the X bar, came around and did both. And that last step, she's hitting me on the head with. Okay. So you shouldn't go back. It ends when you have the R bar and you have the X. Sorry, you have the R and the X bar, and then that's it. Yeah.
Okay. You can continue. I've done.
You're done? Well, I need your paraphernalia. Thanks very much. That's
You're
very
welcome.
good. Yeah. A question came up this morning, which I thought was a very good question. Somebody did not, and I think I answered it. You probably all answered it. Why did I go on and produce a chart with only 1 point? That was a question, right? And the reason I did is because we do this so often, and you do the exercises, and you may lose sight of the fact, why are we doing this? And the reason we're doing this is that once we have built the chart, right, we have done it, we've completed this, we've got now this one here, that's the updated one. We have this one here, that's updated one. What happens now is that you can go back to your client and say, we're ready. I have now your X bar and I have your R chart. We're ready to put it into production. And then you do those, and then you start monitoring for real, right? This stays fixed, right? This taking stuff out of control was just to get it right. Now you're actually starting to monitor, everything is good, and now an alarm goes, and a real alarm goes, you really may have to stop production, and so on. So the first ones are sort of to build the chart, okay? But once the chart is built, then you use it. And that was the only point of that. I have, just to continue with the same style as previous days, looking for an eraser. Oh, there we go. Is, what are we going to do today? So we have, you wanted to see problem 2, so we'll have that, today's problem 2. There was something else about hypothesis testing and confidence interval that I wanted to complete, that we started yesterday. You may not, I'm learning, I'm having discussion with the TA, so I want to share that with you because it's some insight into what's going on. Are there any other leftovers from previous questions that were unanswered? I know there was one that somebody had asked. Is anybody online?
Yes.
Okay.
Before going to the customer, capability reports are mandatory. It must be compared with product specs, not only with process outcomes.
Say that again.
Before going to the customer, capability reports are mandatory. Must be compared with product specs, not only with process outcomes.
Okay, if we talk about Zuko, this is capability. I don't think capability analysis was covered in today's. Was capability analysis a CPK? Okay, we haven't come to that yet. So we have not yet incorporated the USL and the specification limits. The lower and upper specification limits are not yet part of our lingo, not part of a concept. So there may be some of you who are familiar with these things. We are going to the client with a with a chart, with a control chart. We're not yet with capability analysis. I'm assuming, Zuko, that we're starting a process. We want to get this process under control. Capability analysis doesn't happen until the system is under, the process is under control. We've gone to phase 2. We're still in phase 1. We just started going, things are a mess, and we want to bring them under control. Once they're under control, and we got rid of all the problems, so we're in steady state, then we start thinking about capability analysis. What are we capable of producing? At what level of quality? And is that level of quality sufficient to meet the user specification limits? So that's my response.
He says it's not covered yet, but it's based on on your comment of taking it to the client.
Yeah, Mike, taking it to the clients is just, we're rushing to take it to the client to get a process under control. We're just starting off a brand new assembly line. Okay, this is the first time that we're getting off, and it's messy. Things are a mess. So go.
And one more question from Andres.
Yes.
From the X bars chart, how do we go to get mu?
Oh, it is part of what I'm going to talk about next, but the X bar chart that we have here, this then, mu, she's written it down here. Mu is approximate, our estimate of mu, and that's what this little hat is. Whenever, you can write it 2 ways. You can write as mu is approximately equal to X double bar, or you can write it this way, that mu hat is equal to X double bar. So our best estimate of the process mean is this X double bar, which comes from the updated X bar chart. So the center line of the X bar chart, what we label as X double bar, is our estimate of the process mean. And our estimate of the process standard deviation is the R bar over D2 for that. So now we have both. We have the best estimate of the mean, best estimate of the standard deviation for our process. We call them mu naught and sigma naught. I hope that I've answered the question.
All right, continue.
Okay. So we have only 2 items there. I have an open list. If somebody, yeah, so I'm answering questions. The questions that I think I can answer just on the fly without a lengthy explanation, I answer, and then anything else I can put on the list. So from these 2, let's first do this one here, just for today. Okay, so first let me continue from our discussion yesterday. Yesterday we had 2 expressions. We had an expression that had X bar is less than mu plus Z alpha over 2 S over root 2. And we had X bar minus Z alpha over 2 S over, not root 2, root N over root N. And this is the area, if you remember, we had an example, and then we checked whether the sample that we have is within, sorry, this is mu. So this is in hypothesis testing. In hypothesis testing, somebody's saying, I think I know what mu is. I think mu is 20. Okay? So I can calculate this side. I can calculate that side. And let's see from the sample whether I can reject the hypothesis that, let's say we say mu equals 20. That's H naught. And then we put here 20 minus and 20 plus. And then we either reject or fail to reject. And then we had another expression, and let's leave it as mu here. Back again, that's our estimate of mu. And then we had a confidence interval. The confidence interval, I think we all know or should know. And algebraically, these 2 inequalities are exactly the same. So this is the confidence interval. And so strictly speaking, somebody could use a confidence interval to reject or fail to reject a hypothesis. He could build a confidence interval like this. All the information is there. And then this says that mu is between there and there. And now I get a mu equals 20. Does that mu equals 20 lie within there or not? And if so, that's rejected. That's what the gentleman did who was sitting over there yesterday. And I said, think about it. And he was pretty sure that you could do that. And in fact, he's right. You can reject the hypothesis using the confidence interval. Okay? But it's not the same thinking process. And I'll tell you where it makes a real difference. It makes a real difference in control charts. Because when we draw the control chart, we have x double bar in the middle, and then we have here x double bar plus 3 s over root n, and here we have, well, s over root n, or some measure of the, let's say the S chart. We have x double bar plus minus, and let's call this z over 2, z alpha over 2, and let's call this z alpha over 2. And for alpha 0.0027, you get 3 s over root n. Okay? And we're checking whether points lie within here or not. So we are checking this. We are doing a hypothesis testing all the time. And how are we doing that? Now you might say, aren't we doing isn't this a confidence interval? Is this a confidence interval or what? You might be confused by now. You might be sitting there saying, I don't know what. If you sit there and say, I don't know what you're talking about, please raise your hand. Or maybe all your hands are going to go up. Both hands are going to go up. Okay, let me get then to the punchline and see. Okay, we are doing hypothesis testing all the time. And what we are doing is we are saying, I took initially some 25, 30, 40, 50 samples. And I took x double bar. And I got rid of the points out of control. Okay, and I am now pretty darn sure that mu is pretty close to x double bar. Okay, so we replace mu here with x double bar, saying, I took so much data, I'm almost sure. Okay. But a statistician or a real person who really has his head on his shoulders is going to say, no, you don't know what x double bar is. X double bar is really, there's a confidence interval for x double bar, for mu. Mu, you're saying it's approximately equal to x double bar, but it's not. Mu is still lying within a confidence interval. All the data that you collected can only get our knowledge of mu this narrow. You are jumping the gun by assuming that mu is equal to x double bar because you need to build a control chart. You need to do quality control. Therefore, the practicality of the situation demands that you take some approximation. So you're approximating x double bar and mu, and you're doing this hypothesis testing this way. Okay? And so you're doing hypothesis test, hypothesis test. This is not a confidence interval. This is the confidence interval for mu. Okay, so there's a real difference between the two, and you really need to understand. So you're doing all the time, is the system under control? Yes, 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 no, reject. And once you reject, you got to take an action. You can't just sit there and be idle. Now, when I think of this, the chart has already been built. I am now actually using it. Okay, there's a lot of focus on actually building it because that's what you got marks for. But the real purpose for doing this is to use it. And so it's important to realize what it is that you're doing compared to the statistics that you took. You're doing a hypothesis test as the data comes out, checking with that. Okay, so that's what I wanted to say with one. Are you still, is this clear? Clear or clear as mud? You got to ask a question if it's not clear. But think about it if you want to come in. Now, is this important in terms of, getting a mark or something like that? No, but I think it's important in understanding what's going on. Okay. Now, problem 2. So the reason I smiled at Nushin, we sort of, is it following me? No, it can't go that far. It's not. Hey, come here. All right. The reason we, So for just to break the ice, you will be responsible for tonight, today's problem set, which is due. It's a good question as to when this thing is due. Right now we're saying it's tonight, right? 11:55. But we could change it to Sunday, 11:55. Right? It's Friday, 11:55. But the only reason for making it tonight, 11:55, is just getting it off your desk and giving you the weekend to maybe prepare. So I just posted some exercises for Monday. Okay, so if you want to look ahead and look at the videos for Monday, you can start doing that. Over the weekend, I will probably finalize the exercises for day 6 for Tuesday. So I'll be adding those on as I get around. We do have exercises, but there's this debate that goes on between me and the TAs over wording or over slightly, issues and so on. So I don't want to put them out there until I'm comfortable with them and ready to give them to you. So, what? You mean all the exercises? No, I'm not ready for that. So I know what you mean. Like you think I have a whole battery of exercises with the last. No, we're not there. These are the exercises that we give you, and the problems are kind of well thought out, I find. I think they have some fuzziness in them and lack of clarity in them, which I think is healthy because that's what life's like. Okay.
There's one vote online for Sunday.
Yeah, there's one vote. Okay. Is there a way of taking a poll? How many people are online?
17.
Oh, we have 17, so we have a quorum. We have, we do have most of the class is here. So there's no way of taking a poll, but they can say.
Not on here, no.
Not on here, but they can say.
They can all vote. They can say Sunday if they want to.
Okay, so.
And I can count it.
Yeah, maybe let's do that. Okay, so the people here, how many people would like it Sunday and how many people would like it? It's either one or the other. I'm not going to make it, well, like, huh? Okay, raise your hands. We have 4 or 5. It's kind of an unpopular vote to say no, right?
Is it the assignment? Or
Yeah. So you know what? Given that I'm okay. Sunday is fine. Sunday 11:55. It will. Yeah. I'm assuming that then you are okay with the TAs not marking over the weekend, right? That's also there. So they'll be happy, right? You're happy. The only thing is you'll get it back a little bit later, but I think the drop date is today. So there was a rush in getting you the exercises marked, the assignments marked. So you have marks to all 3 now, okay? Yeah, Sunday. I'll post an announcement. Okay. So consistent with that, you will be responsible for submitting both problem 1 and problem 3. I know I was going to ask you to do that anyway. Okay, problem 1, and we'll do problem 2. Problem 1 and problem 3 will be the assignment. You have a whole weekend.
There is a request to make CrowdMark available for submitting already tonight.
Yeah, no problem. Yes, I will do that. I had a real scare today because I put the deadline for yesterday's assignment July 17th. I made a mistake. And so we couldn't start marking until the deadline is over. And I thought, that's it. I thought the software wouldn't allow you to change the deadline once you've sent it to the students. And then what, right? But thank God I was able to advance the deadline, so we were able to mark. Okay, so you want the CrowdMark posted. Okay, so let's, so problem 3 is really interesting. I know there was a large number of people who asked me to do it, but I think it's good for you to think about it and to try to do it, so that I'm happy with that. Now, problem 2. Problem 2 deals with the MR chart. Okay, the I at MR chart. Okay, so the problem with the I chart when n is equal to 1 is that you don't have any variance. You don't have any estimate. There's no variance. There's only one observation in every sample, right? So you cannot get any range. And you cannot get R, you cannot get S. So what do? So the way, as you saw from the video, you then use 2 consecutive units as an estimate for the range. And that's called the moving range. So it's xi minus 1, right? Are you okay?
No, this power bar doesn't like to charge, so I think this is
Is your, okay. All right. Does that affect the other one? Okay. All right. The light's on. Okay, so the MR chart is a little bit different in the sense that the way it's set up, and it's as simple as taking the data. I mean, I just did that before I came here. I just took the data, plugged it into Minitab. I don't know what the problem is with problem number 2. So set up the I and MR charts with 3 sigma limits. So you go into Minitab, you put in the data, you choose the individuals, choose for individual units. I think there is a chart there, and then I think there's a choice of the X. Now the I chart has also another name, X chart. So sometimes it's called the X chart, and sometimes it's called the I chart. Okay, and I do mention that in the video. And so you pick that, you open it up, and if you run it, I think right away, if you run the IMR chart, I think all points will be in control. Is that what you found? So there really is no more work, right? So that's why I do it that way, because I feel lucky, I do it, and the game's over. Whereas in the other way, I first have to do the R chart, then I have to do the X chart. So A is okay. Is the process out of control? I don't think you found that they were out of control, right? Did anybody here or anybody online can elaborate as to what the problem was with problem 2? Maybe it's the last point. Maybe it's C. Is it C? C part of problem 2. Estimate the process parameters. So estimate this process parameter. So mu will be, an estimate of mu will be to X double bar. So since everything is under control, there's nothing more to do, right? Mu is equal to X double bar. And for sigma, you have to use the old R bar over D2. That approximation. Except you don't have an R bar, but you do have a MR bar. And the MR bar is in the MR chart. It's the center line of the MR chart. Yeah?
Okay,
Yeah.
For question 2, where do we need to set the 3 sigma limits?
The default in Minitab is 3 sigma. So it will automatically set everything to 3 sigma. So you just put in the numbers, press the button. Now, if you wanted to do this in Excel, right, it wouldn't be that difficult. But you had a question? In Minitab, if you wanted to, I believe in the options, there is, if you go to the options, I think there's an option to change that. Okay. There is or there isn't? You were not able to find it? Okay. I think in the question we allowed you to use 3 sigma limit, so that's the standard, right? But if you wanted to change it, I'm quite sure that in the options you can change that. But have I used that? Have I checked it? I haven't checked. So if you find that you can't, then tell me, and I'll see if I can find it. Okay. Yeah. Any question?
Isn't the estimate of the mean X bar?
The estimate is the center line. Okay. If you look at the center line of the X chart, thank you. For the X chart, you're right. For the X chart, it's X bar. Thank you for that correction. It's the average of all the numbers, because you only have one number. So it's the average of the number starting with 19.33 down to 19.79. And I believe the average came to 20.038. Okay, 20.038 was the X bar. Okay. Yes, because normally you see X bars, and so the average of the X bar is X double bar. For the X chart, you see X's, right? You just have just one of observation, so the average of the X's is X bar. Okay, so the center line is X bar, and sigma hat is then R. Normally it's R bar over D2, but you don't have R bar, but you have MR bar over D2. But now the question is D2, D2 needs a sample size. What's the sample size that we're using? 2, right? So just a matter of going and looking up what D2 is, and D2 is 1.128. And so, and the average of the MR bars, I think, according to this, is 0.845 over 1.128. And so it came out to 0.75 roughly. And those are the parameters. Yes? Yes, please.
It's asking if we do want anything different from, okay, so it's one. So isn't the estimate of the mean bar that the answer? And so we can just copy and paste the data into the tab, then we can just get the instant S chart. So say no need to adjust the limit because it is default already.
There's no need to change you can just, in this case, when everything is under control, you can just take the chart that you get from Minitab, cut and paste, and put it into your answer. Right? I don't at this stage, I am not asking you to to do it well, there's no need to adjust the limits, right? There's no adjustment to be made. There's nothing different. Your question might be, well, shouldn't we be doing what Minitab? This looks too easy, right? So sometimes I might ask you to do it in Excel, okay? And that's just a matter of having access to the formulas for the chart. For example, there was a need for me at some point in one of the exercises. Was it today's exercise? Or it is the next exercise, I believe, where I did the chart in Excel. Because I just wanted to do it in Excel, okay? So you're free, we don't demand that you do it in Excel, but we do expect that you know what's going on. If we give you enough information, we don't expect you to memorize, we will give you the table, okay? I was thinking on the final exams, rather than having to look at online because you don't have online access, we'll give you a copy of that table with all the A2, A3, D2, D3, whatever, all those constants. So that's not an issue. So if you had to do it in Excel, if you're given the chart, you're given the numbers, you just put them together. There really isn't that much to understand to demand that you do it by hand or in Excel and just do it Minitab, and that's fine. Okay. Now the question 2 is fairly straightforward. Was there a difficulty? I still want to know what the issue was. I see. Okay. So it was the disbelief that we would ask you something so easy. There must be something wrong. I must have missed something. Well, guess what? You didn't. Okay, you didn't. But problem 3 requires a little bit of thinking, and I'm not going to divulge what it is that requires thinking. I'll let you be on that. Question 3, my TA says, well, you have to give them more information. I said, no. When it says that mu naught and sigma naught in problem 3, it's the mu naught and sigma naughts based on the information given in the first 2 questions, right? I mean, because I haven't given you any mu naught and sigma naught. So that's that. Yeah, so it's 25 to 5. Any questions from the...
Disbelief is key for quality control, winky face.
True. You always have to be suspect. If anything can go wrong, it will. Okay, just give a minute or so, or maybe less. Yes? No, please.
You were talking about process output control and processing control.
Correct.
So for
Why cannot add?
Yeah, because actually it's something that is out of control and something that is in control.
Okay, so as a general answer, I will say that the calculation of beta and the logic of calculating beta we have not covered yet. I don't think today's videos talked about doing beta by hand, right? So when you see what's involved in computing beta, you'll get an appreciation for, oh, that's what we're calculating, okay? Beta is not a constant. Beta is a function of n, of the shift, and there were three, n of the alpha. So it's a function. So you might say, well, what is that function? How does Minitab calculate that power curve? Okay, so that you'll find out on Monday. Okay, in the videos on Monday, I explain, and explaining how beta, and the reason I did that is because explaining how beta is derived is not that straightforward. So it takes, you can use graphs to understand it. It's not that difficult, but I thought as a first going into this, let's just get the calculation for Minitab. Let's understand what ARL is, not ARL, not an ARL1. Once you understand that beta is a complicated function of, it's not that complicated, but it's relatively complicated. You cannot just do it on the top of your head, okay? Then, and it's a consequence of alpha, n of n, n of the shift. Then we cannot add. There's like a long road given alpha, n, and the shift to beta. All I can tell you is once you have it, then the ARL is 1 over 1 minus beta. That the expected number of false alarms, if you like, before you see a violation, right, is 1 over 1 minus beta. Does that answer your question? Okay.
Okay, there's a question.
Yeah.
Can you explain how to get the D2 again?
Okay, the D2 is okay. So part of this is historical. If you're an engineer, you're not scared off by a standard deviation. Standard deviation is a big deal. It's a standard deviation. Yet the control and Shewhart industry, they felt that the range of a sample was more meaningful to people working. They were addressing, you have to realize some of the history behind this. When I was a kid, I would buy a toy, and if it said made in Japan, it was a piece of garbage. Okay? The stuff that was coming from the Far East was really very low quality. People in the quality field, the 50s and 60s, people like Shewhart, and there's another field, you guys will know it, some of you will know it, they realized that without quality control, without statistical quality control, industry is going to continue producing lousy products. And the American industry had the philosophy that we need to build in lousy quality so that people will replace them. We can't build a car for 10, 15 years. We're going to go broke. We have to build shouldn't be any attention to make them so high quality because they'll need another car in 5 years. It's good for business. You're telling us to spend money to build high quality just to hang ourselves. Forget it. So these gentlemen went to Japan and they sold the Japanese on the idea that in order to compete in the world market, they need to increase their quality control. And the Japanese bought it lock, stock, and barrel, and umpteen years later, they produced much better quality than anybody in North America and then anybody in Europe. Okay, the Europeans were making cars, very high-end cars were very good because they were very expensive to build, hand-sewn things, craftsmen. The Americans were producing with Henry Ford, one after the other, and the quality, well, so be it, they'll buy another one in 5 years. And to this day, not that long ago, GM, they made cars, and whatever wasn't working would get fixed at the end of the line. So you'd have doors that don't fit. Well, somebody's job was to adjust the door before they sold it as a new car to close, okay, because it was not perfect. Now, the quality control has quality control stations all along, and you don't allow a part to go to the next station until it's perfect, okay? That means that the people on the line have to understand what you're doing. And so they felt that a standard deviation will deal with the range of a sample. If the range of the sample is too big, then that's bad. If the range is small, that's great. Right? Now they had a problem. How is the range related to the standard deviation? Because all of our math deals with standard deviation. right? So they did studies, and in the studies it came out that if you look at the expected value of the range over sigma for a given D2 is equal to DT for given sample size. So D2 is a function of n. They were able to actually tabulate that if you take that the expected value of the range in a sample of size n divided by the standard deviation of that sample, the expected value was a constant. It was constant. That's a great observation, that the range and the standard deviation are related so well. Okay? And if that's the case, because sigma is a constant, you then get D2, you then get sigma equal to, you get an estimate of the sigma anyway, equal to R bar over D2. Now, these values were just experimental, if you like, okay? Maybe they were analytical, but nowhere have I seen an analytical function that generate, all I've ever seen in my life is tables. So somebody actually published a paper. It'd be nice to see the original paper and say, these are the D2 values, and this is what I found. And it would be great to get that from a historical point of view, okay? Now, those D2 values are, if you go to the internet, Google, D2 table statistics, or even just D2 table, you will get a number of sources, PDF, you open it up, and there are the values. You go to the back of the book, I think it's page 270, because I just looked it up this morning. There is a factors, I think it's the table starts with factors or something. You look up, and you'll find a table, and you'll find n listed along here, 2, 3, 4, 5, 6, and you'll find a whole bunch of characters here, and one of those characters is D2. And if you look, this is n. If you look at for 5, now I was talking about D2 for the moving range. For moving range, the moving range is xi minus xi minus 1. So it's 2 values. And because it's 2 values, we have a sample size of 2. So n equals 2. So we need n equals 2. If you look at the first entry for this, it's 1 point, by the end of this course, I'll know it by heart. 1.128. And that's in any of these tables that has all these A's and D's values, we'll have then the T2 value, you just look it up, n equals 2 is 1.128.
Someone's asking, do they need to memorize
No.
when to use D2, D4?
You need to memorize this equation, okay? This equation you need to memorize, because that gets reused all the time. Because we use R bar charts because of history. If it would be just engineers, all we would have is the X bar and S chart. The X bar and S chart makes most sense to me. I don't know why we ever bothered with range, but we bothered with range because we also want the people on the assembly lines and make it more transparent to managers what the heck they were dealing with. You tell them standard deviation, it's a square root of a square, they'll say, what are you talking about? You tell them it's a difference between the largest and the smallest value in the sample, they'll say, that makes sense. That should really be small, right? So that's where the R bar chart, and that's why, because this is quality control, and Shewhart charts with R bar are very much out there, okay, that this relationship takes you from the practice to back to the statistics where you need estimates of sigma to be able to plug into your normal distribution. Does that?
Someone else asked that, or said that's type 2 error regarding question 2.
In question 2, there is no type 2 error in question 2. Today is consider the data set up IMR chart. Is the process out of control? The process out of control is you look at the points that violate the upper and lower control limits. There's no calculation of beta at that point. Estimate the process parameters just at the mean and standard deviation. So there's no computation of beta involved in doing question 2. But
Okay.
I know that there are a lot of concepts in control, there's a lot of stuff floating around. I hope, the one good thing is that other than capability analysis, what we do between now and day 9 is all along the same. We'll continue talking about ARL, we'll continue talking about alpha, about beta. it's not like we're going to take a turn all of a sudden on Monday or Tuesday, Wednesday, and switch to something totally different. Capability analysis is related. It's a little bit different, but it's still consistent with what we're talking about. So hopefully the soak time will work.
So for MR, the population is always equal to 2?
No. For MR, the sample size is always equal to 2. The sample size. We are taking samples. The population is millions of numbers. The population is out there. It's in the clouds. It is generating these numbers, these X's. There's some, we believe it's a normal distribution that's generating these numbers. 11, if you go down, where did 11 in 19.33 and 19.99 and 20.13, where do they come from? Those are numbers that were generated by some kind of normal distribution. Okay, I don't know what the mean is. I don't know what the standard deviation is, but our belief is that it's some kind of normal process. And we need to, for each sample, need to have a sample variance, but there's only one. So how do we get a sample variance? So we cheat and we take we take the difference between it and its neighbor, and that's the range. So we take a moving range, which is the difference between these guys. And then we take the average of it. There's no absolute, is there absolute value? Am I missing absolute value in the MR? Do I track the absolute values or just? If we put the absolute values, yes, okay, yeah, sorry. It's the absolute value difference between adjacent observations. And now when I need to relate sigma to, so this now is, in this case, it's MR bar, and then it's MR bar for a sample size of 2. So for the MR chart, the sample size that I use in the D2 is always 2, because I'm comparing these two numbers. Yes? Mm-hmm. Okay. And there's no such thing as a stupid question. This is too, the course is too short for you not to ask questions. If the course is 3 months long, you figure, maybe by the 3rd week I'll get this. But it's too short not to ask questions.
Can you give an example of a situation where IMR chart is used?
Oh, very much so. The IMR chart is used when you need to check every unit, okay? It takes too long to produce a unit, or every unit is too, we want to check every single unit, okay? Maybe because maybe the conditions change too much, like let's say it takes 20 minutes to produce a unit. We're afraid that by the time we produce the second unit, something might have broken down, something might have happened. If you remember, I talked about rational subgroups. When you take a sample, you want to make sure that the conditions, that your chances that the conditions stay unchanged while you're taking those samples, those observations in one sample are the same, that nothing will change while taking a sample. So if your products are produced fast enough, you say it takes 10 minutes to, it's unlikely for these 10 minutes or something, because we're going to take one now and take one an hour later, and it takes us 5 seconds to collect the sample. And it takes an hour later 5 seconds to collect the sample. So the chances of something going wrong in exactly those 5 seconds is minimal, okay? And that's why it's called the rational subgroup. They're very close. The sample is very similar conditions. When you have a process where it takes too long to make a product, it takes 20 minutes to make a product, and conditions could easily change, then you don't want to wait an hour to look at 3. You want to test every unit. You want to, do some kind of a measurement or testing for every single unit. It's very common. And so whenever you're testing every unit, you need to use the I chart or MR chart. Now we'll get later to something called QSUM and UMA charts. That's the last 2 days. Those also assume that you really want to know really fast when the process is under control. If you really want to know when the process is under control and you can afford to, then test every unit. Does that, I hope that helps. Yeah, so I'll just be blunt, is that I worked for umpteen years, 23 years at Hydro, and most of my work was related to optimization models and operations research. So I have war stories and first-hand experience. Quality control, I know some reliability because we were involved in reliability studies and so on, but strictly quality control, the way I teach it here is like, I know the material, but in terms of applying it, having been in a factory and after actually using it, I haven't. And so if anybody's got any war stories they want to share just about the practice of being a quality engineer during any of these sessions, you're most welcome to the mic and to share your stories with the rest of us.
That was not a question, that was a joke about how we misestimate the question for being difficult.
Oh, which one? The one about the wing?
That's type 2 error regarding question 2.
Oh, oh, so I'm sorry. Okay, sorry. I'm too high strung. Okay, sorry for missing that.
Sarcasm doesn't always translate.
It doesn't. I think maybe yeah, online has some limitations. Okay, it's 10 to 5. It's a nice weekend I hope we all have. And that's it. We'll call it a day. Thanks very much. Whoa. I think we all need a break in this rhythm.